Hello everyone, here I am back with another topic in this subject thermal science. So let's start. The topic will be Carnot cycle. Okay, what I will be covering, what is the reversible process, what are reversible process, and some basic about Carnot cycle. So first of all, what is Carnot heat engine? Reversible process, reversible versus irreversible process. Reversible process is defined as a process that can be reversed without leaving any trace on the surrounding. Okay, and both the system and the surroundings are returned to their initial state at the end of the reverse process. That means that from where they started, finally they come to that process. That is mutually convertible. Now reversible means they can come back to their initial state. This is the process only if the net heat and work exchange is zero for the combined original and reverse process. This is a theoretical process, right? So we mean to say that no process is reversible in nature. Reversible is just a theoretical concept. In practical, it is not possible for any process to be reversible. Or the real process which are really occurring, they all are irreversible. That means that they cannot come to their initial state once they are initiated. All real processes are irreversible, and the reversible process is a theoretical process used as a limit for the corresponding irreversible process. So to study any reversible process, we take the help of reversible process. That is just a reference. For just reference purpose, we take the reversible process. Irreversible is caused by friction, right? So when there is friction, then irreversible processes occur. That is why we always say that friction is a very important phenomena. The Carnot cycle, right? We have already mentioned that heat engines are Carnot devices. In my last slide I told you about that. Reversible cycle cannot exist because of the friction. The Carnot cycle is a theoretical reversible cycle processed in 1824 by Sadi Carnot, a French engineer. Okay, the Carnot cycle, in next slide I will show you. There are four processes actually: reversible isothermal expansion, reversible adiabatic expansion, reversible isothermal compression, reversible adiabatic compression. This page number actually I had already discussed you in my lecture also, in the Pekenak book which I had shared with you. Mentioning here. So look at this Carnot cycle, ideal Carnot cycle. First 1 to 2 is the isothermal process, right? And 2 to 3 is the adiabatic process. 3 to 4 is the isothermal process again, and 4 to 1 is the adiabatic process. And we have pressure against volume, and T is the temperature here. You can see that there are, the graph goes from 1 to 2, 2 to 3, 3 to 4, and 4 to 1, where work done is equal to Q initial minus Q final, Q1 minus Q2. Carnot cycle process 1 to 2 is expansion at constant temperature. Okay, in previous diagram also you can say that the gas is contact with the source at high temperature. As the gas expand, high temperature changed by dT. However, the heat input from the source will increase again T to Th in a reversible way. At the end of the process, the gas has absorbed Q of H. Carnot cycle. Process 2 to 3 is the adiabatic expansion, where temperature drops from TH to T2. At state 2, the reservoir is removed and replaced by an insulation. The gas continue to expand slowly, doing work on the surrounding until process is 3 to 4, which is also known as isothermal compression process. At T1, at state 3, the insulation is removed and the gas is in contact with sink at lower temperature. The piston is pushed inward by an external force, doing work on the gas. As the gas compressed d by dt, but the sink will absorb this elevation of the temperature. At the end of the process 3 to 4, the gas has rejected Q of lower temperature. And the last process is adiabatic compression process, where temperature rises from T to TH, higher temperature. The sink is removed and the insulation is put back when the gas is compressed in a reversible manner. The gas returns to its initial state, which completes the cycle. Okay. Now the efficiency of an Carnot heat engine. The second law of thermodynamics states that no heat engine can have 100% efficiency. Okay, in my last slide I told you that the maximum efficiency is for reversible cycle. As Carnot heat engine, Carnot efficiency is equal to theoretical reversible 1 minus QL minus QH is equal to 1 minus TL minus TH, where L and H are the lower temperature and higher temperature, and temperature is always taken in Kelvin scale. The Carnot refrigerator, it operates on the reverse Carnot cycle. The coefficient of performance of any refrigerator, reversible or irreversible, COP of refrigerator is given by 1 by QH minus QL minus 1. Is given by COP of HB is given by 1 by 1 minus Q of L minus Q of H. COP of reversible process, reversible refrigerator, COP of refrigerator 1 by TH minus TL minus 1, and reversible heat pump is 1 by 1 minus TL by TH. Thank you. With this I come to end of this slide. In this slide I had discussed you about the reversible process, irreversible process, and about the concept of Carnot cycle, and what are the COP coefficient of performance of heat engine, heat pump, refrigerator and heat engine. Okay, thank you guys.